So there's been a video that I've wanted to do for a while and I haven't because I've been kind of scared about doing it live. And I know it's going to sound weird, but it's all about Fleming's left hand rule. So that's what we're going to get into today is Fleming's left hand rule. Now, when we're dealing with Fleming's left hand rule, we're dealing with our left hand, obviously, and it's all about the direction of current flowing in a conductor as it cuts a bunch of flux lines, which seems like there's no big deal there. Why would this even be an issue? Except for this, and this is normally like the most fun I have when I'm teaching in class. This is our new gang sign, just so you know. But here we go. When we have Fleming's left hand rule, we're using 3 of our fingers in our left hand. We have our thumb, our forefinger, and our middle finger, okay? You can see where I'm going with this. Our thumb is the thrust of the conductor through the field. So if I have like a north pole and a south pole sit here, and my conductor's going upwards, like it's thrusting this way, then my thumb would point up. If it's coming down through the field, it's going down like that. So that's my thumb is the direction of thrust, or direction of current conductor through the field, magnetic field. So my thumb is the direction of the conductor through the magnetic field. My finger, this finger here, is the direction of flux lines. And we all know that flux lines flow from north to south. So that's what's happening here. So north to south heading this way. If I had a north pole here and a south pole here, then my forefinger is heading this way. If this was north pole and this was south pole, my finger would head this way. Now you notice that you can see I'm using my left hand always because it's Fleming's left hand rule. Now, and I apologize for this, the middle finger, this finger here, this is the direction of current. Current flows from your knuckle to the tip of your finger. All right, and I'll show you, I've got a crude drawing of a picture I'll go over with you in a second here. I'm gonna fire up the webcam, fire up the old iPad over that I got here, and we'll see it. I don't know why I keep this finger up. So anyways, I apologize to any parent walking by at this juncture. I'm not doing what you think I'm doing. I'm showing them Fleming's left hand rule. It's our new gang sign, right? So, direction of conductor through field, north to south, direction of current. North pole here, south pole here, thrusting up. North to south, thrusting up means that the current is flowing from my knuckle this way. Now pay very close attention to this part, very close attention. We are creating voltage by doing this, right? We're taking a conductor, we're thrusting it through a magnetic field, it's inducing a voltage, which is a fancy way of just making voltage. With that in mind, it's becoming a source. Now, depending on how you want to look at it, and we're subscribing to electron current flow through in this, so we know that as current flows through a load, it flows from negative to positive. As current flows from a source, it flows from positive to negative, all right? So when we do this, when we use Fleming's left hand rule, you can throw a little tat on your knuckle there. That's positive because current's going to flow from your knuckle to the tip of your finger, positive to negative. Fleming's left hand rule. Remember that. So north pole, south pole, thrusting up. North pole, south pole, thrusting up. Current is heading towards me from my knuckle to the tip of my finger. That's Fleming's left hand rule. Let's just hop into the webcam. I know it's not going to be as good as this camera, but I'm sure you'll survive. And I'll show you this nice, beautiful drawing I've done to show you exactly what I mean. Okay, I'm recording off the webcam, so I'm sorry if the resolution's not the greatest, but the sound's better because I got this wicked mic in front of me. So what we're gonna do is, I'm gonna take my iPad here, I'm gonna draw it through here, okay? So it'll all make a little more sense as I draw it through. And I'll show you how it's different too. All right, so let's pull out the old pen tool here. I'll give it a nice blue color. We'll say that this pole here is north and this pole is south. Okay, so we've got those set up. Then I'm gonna go ahead and I'll change the color again to a nice pinky hue. And I'm gonna say that the direction of flux lines is heading like this. And I'll draw arrows to show. So we know that flux always goes from north to south, right? And so it goes like this. This isn't so bad. And it fringes out a bit. We won't get too much into it. But it's flowing this direction, right? North to south. So that's flowing in that direction. So now I've got this going on. I've got this, at least we've got figured out. All right, now I'm gonna draw, and I apologize for this in advance, but let's draw a nice little conductor, and it's going through here. Not so bad. And let's say that it's gonna be thrust up, okay? So I'm saying that this thrust is this way here. So now I've got everything I need. I know that this is my 4 fingers, which is heading north to south, so let's just write that in there. Let's just write that, go with a black pen and go forefinger, is heading this way. We know that the thumb is thrusting up, so that's thrusting up. Then let's see which way the direction that the current flows. Well, if this is going north to south and this is thrusting up, that means that my finger is going knuckle to tip towards me, right? But if you look at the screen here, it's going knuckle, which is right here. This would be your knuckle basically, to tip. Make sure you've got your left hand out as you look at this. Knuckle to tip. Then, as we talked about a couple minutes ago, that means that my current is flowing from positive to negative. All right, so that's current flows from positive to negative, which means that this point here is more positive than this point here. So we've got that figured out. Now, just to prove my point, and we'll get it going the other way here, let me just erase everything. All right, that's the fancy dancy. That's what I love about this new technology that we can use, this newfangled tech. Make sure I don't, I 1 second there. I didn't want to get rid of the actual poles. We want to get north to south there. Go like that. We'll get rid of this. We'll keep some of those flux lines in because honestly, they're going to be there anyways. So let's get the flux. Let's get the flux over here. So we got the flux going this way. The only thing that really changes now is what I'm going to change things up on you. So just don't worry about it. Don't worry about it, okay? Okay, so then I'm saying that this is north and this is south. So things have changed up, okay? So that's north and that's south, which means that my flux lines are heading this direction. So this is north to south. This would be my forefinger, right? Now let's, for all silly things, let's say that we've got the same conductor now, but it's being thrust down. So it's going down through here. So that's my thumb is going down. Now we're gonna bust our wrist in a second here. This is the best part of it, is when I watch students writing tests, I see them like busting a move here. All right, so I'm going north to south this way. Okay, this is my north, this is my south, north to south, thrusting down. So I've got it has to go down through here, which means that, again, guess what? I messed with you because this is now still, here's my knuckle, here's my knuckle. Going this way here, that way there. So that ends up being, if I look at this, this is going to be, again, positive to negative. But that's only because, now think about this, before, when this was north and south, I was thrusting up. Now this is north and south and this is thrusting down. So it's all relative. It's all gonna still be the same, same polarity. But if I did one more thing, let's say that I thrust this thing up. Let's just change this up so I don't confuse you too much. So if I change this and I thrust the conductor up through here, watch what happens. So I'm going north to south, but I'm thrusting up, right? North to south like it has to, but I'm thrusting up, going up this way. My thumb's got to go up, which means now that my knuckle's here and the tip of my finger's here, unless you can bend it some weird way. My knuckle's here and that's there, which means that this all changes. Boop, get rid of that. And this now becomes, on this side, this is positive and this is negative because here's my knuckle and here's my tip, right? Knuckle, tip. That's Fleming's left-hand rule. So next time you see me out in the street and you say, hey, you're that Electric Academy guy, flash me our gang sign. Fleming's left-hand rule. Remember, use the left hand. We subscribe to electron current flow here at the Electric Academy. See you on the next one.